Hello students, how are you all? I hope you are doing well. Then today my video is about screening effect or shielding effect. In yesterday class, in previous videos, we already discussed about the periodicity and periodic properties and how many periodic properties are there. So all are we already discussed about in our previous video. Now we are going to discuss about this today's session, screening effect or shielding effect. Screening effect also called as shielding or shielding effect. Okay, those are equal. Okay, so in a atom, we already know about the atom. In a multi-electron atom means, what is the meaning of a multi-electron atom? Which are having the more number of electron. That kind of atom is called as multi-electron atom. Here is an atom. Let us consider here it is an atom. It is having orbits like this. And let us consider this is the nucleus. Nucleus having zero charge, we already know. And here also protons will be present. Proton having positive charge. And these all are the orbits. This is the electrons. It is appearing pink color, no? These all are the electrons. Electrons having negative charge on inner students, right? So let us explain this one. This is the outermost shell. Also we called as outermost orbit. Okay, and also called as valency shell, valency orbit also. Okay, don't get confused by seeing this one. Okay, this is a valency shell, also called as a outermost shell or valency orbit. When the electrons present in the outermost electrode, which one is finally appearing na last present, that shell only we are calling a outermost shell or valency shell. Okay, when the electrons are present in this shell, these electrons are also called as a outer electrons, at the same time also called as a valency electrons also. Okay, this is the orbits. These orbit also, this orbit is a valency orbit, and whenever electrons are present in this orbit, that electrons are outer electrons or valency electrons. Okay, so this is the inner shells which are present along with this orbit. This is the inner shells. This is inner electrons. Okay, so in a multi-electron atom, what will happen? The electrons which are present in the inner shell, here the electrons, no, the electrons which are present in the inner shell, they are forming as a screen. Okay, so what is our concept? Screening effect or shielding effect. Here the inner shell and this is the inner electrons, no. Okay, so the electrons which are present in the inner shell, they will forming as a screen like this. Screen, we know already screen, na? Okay, this is a screen. We are for these inner electrons are forming as a screen. Then what will happen? See the student, nuclear attraction will be decreases on the outermost electron. Nuclear attraction will be decreases. Why? Because here these inner electrons are forming as a screen. Because of that reason, nuclear attraction will be reduced from here to outermost electron. Okay, so the electron which are present in the inner shell, these electrons are present in the inner shell, they are forming as a screen. We know already these electrons are forming as a screen here like this. Okay, forming as a screen. Then the nuclear attraction completely restriction. Here to here nuclear attraction will be present, no? Okay, are you able to understand? This is a nucleus, this is a outermost electron, that is valency electrons. Here to here attraction will be present, right? By the way, this screening effect, these inner shells are forming as a screen here, na? This screening effect attraction will be reduced from here to here. The nucleus is unable to focus. This nucleus is unable to focus on outermost electron. Okay, this nucleus is unable to focus this outermost electron like a valency electron. So this particular process is called as a screening effect or shielding effect. Are you able to understand, students? This is a nucleus, attraction will be present here, and this is a outermost electron. Okay, because of the inner shells are forming screen here, because of this reason here to here nuclear attraction will be reduced. Understand? Okay, like that screen these electrons are forming, this particular process is called as screening effect or shielding effect. Suppose, okay, then but suppose I will take one example. While we went for a movie, okay, so just we sat in our chair. Let us consider ourselves, we are the nucleus. We are watching the movie now, we are nucleus. Just consider this is a nucleus. Nucleus, ourselves is a nucleus. Then the screen which is there, let us consider that is the outermost electron. Cinema theater, the screen is there na. This is the outermost, this is the screen. We are sat here, this is the cinema theater screen. Let us consider this is ourself and this is the outermost electron. Screen is the screen, projector like a screen is there na, that is outermost electron. And next in front of us one more row is there, one or two rows are there. Unfortunately 2 or 3 members, 2 or 3 very height and tall persons are came and sat here, unfortunately. Okay, then what will happen? Those persons are who are sitting on a front side there na, that persons are very tall. We are not able to, then what will happen? We will feel very difficult to see the screen properly. Why? Because this person's height is very large, no, very tall. Okay, so because of that, but that height, what will happen? See this, we are not able to see the screen properly, right? We are not able to see the screen properly. Then these peoples who are sitting in front of us, these peoples are completely shielding us. If these peoples are normal height, nothing will happen in that. We will see the screen properly and we will enjoy the movie very nicely. But here these peoples are very height, very tall there na, so that's why we can't able to see this screen properly. So these persons are completely shielding us, yes or no? So gradually we will feel very difficult to watching the movie. So like that inner shells are forming as a screen, so reduce the attraction from here to outermost electron, outermost orbit, right? So this is called as shielding effect or shielding effect. For your easily understandable sake, I gave some small example. If you understand means nothing will happen, otherwise I will give the one definition. See, so that is one definition. In a multi-electron atom, the electrons are present in the inner shell, act as a screen and reduce the attraction of nucleus on outermost orbit is called as a screening effect or shielding effect. Again I am repeating, see the students definition, listen carefully. In a multi-electron atom, the electrons are present in inner shell. The electrons are present in the inner shell, act as a screen and reduce the attraction of nucleus on outermost orbit is called as screening effect or shielding effect. Then what will happen? More the number of electrons, more the number of electrons in the inner shell, more is the screening effect. Then less the attraction of nucleus of outermost orbit. This point is very very important. See, so more the number of electrons in the inner shell. If more the electrons are present in the inner shell means what will happen? More screening effect will be present, right? Then what will happen? Lesser attraction of nucleus of outermost orbit. Then this is the screening effect. The screening effect is calculated by using the one contact formula. So this screening effect is also calculated with the constant. That constant is called as screening constant or shielding constant. This is represented with the sigma, right? So this screening effect calculation will be I will upload again. Then this is our screening effect class. So please focus on shielding effect and screening effect. So these calculations next video I will upload. That screening effect based on the Slater rule, for every atom we will calculate the screening or shielding constant. So these all are concluded with the Slater. He is a one person. He concluded one formula, that is Slater rule. That particular Slater rule we will calculate with the screening constant. Next video I will upload the screening constant formulas. Okay, thank you for watching.